Hey everyone, the following series of videos will be all about the grid. That is the underlying data structure that drives the grid manager, which is the heart of this toolkit. I will talk about how data and information is stored in this grid, how it stores information about the location of tiles, or whether or not there's a unit on the tile, how to access the information of these tiles, how to store new information in them, and how to manipulate it in various ways. So this is sort of these are core concepts that are necessary for understanding how this toolkit functions, for you to be able to really customize and add your own features. It's very useful to understand how the grid works on a lower level, as it is central to almost all aspects of this toolkit. So to get started, this is just a basic startup level that you get when you create a new level in Unreal Engine. We'll just delete what we don't need here, like the player start and this block, and just add a grid manager as a starting point. So we go to core and grid, add a grid manager. I'm gonna put it at location 0 here. And in the settings, I'll resize it to a size of 6 by 6. There we have a grid. And then I'm going to add a unit, just this regular debug unit here, and one square. So here we have a very basic setup that we can use to demonstrate some of how the grid manager works. So this is how the grid is represented sort of visually, as this 6 by 6 grid of static meshes, but on a lower level it is really represented as a series of different arrays, or really maps in later versions of the toolkit. So all of these are represented by some index in this array or map. So for instance, there's one array that keeps the location of each of these tiles, and there's another array that stores where you have units placed on the grid, and so on. If you look in the grid manager, let's see, then you will see these under grid arrays here in the variables. You have the grid units, which stores the position of units, and grid locations are the locations of the various tiles. Grid big indexes are used for big multi-tile units to see which can be occupied by larger units, and so on. And you have many different of these sorts of maps in this case. So you can see here for the grid units, it is a map where it has a key which is an integer, and all of these grid arrays, you can see the key is an integer. So this is kept consistent on all grid arrays, so that you know if you find one particular key, so you have a location of a tile which is at the particular key, then you can check the same key at the grid units map to find if there is a unit placed on that particular tile. I'll get more into details on what all of this means a bit later on. Now this integer key that is tied to all of these arrays is in all different parts of the toolkit, it is generally referred to as the grid index, as you can see, for instance, here in this function. And there is a useful sort of helper function that you can test out to access stuff on the grid. So I'm going to demonstrate this. This is something I use for debugging a lot. So now I am in the event graph of the grid manager, and I'm going to add a hotkey event here. Let's see, a hotkey, a keyboard event when I press Z, could be anything. Then I want to use this handy helper function, which is the get hit tile location and index. Now this is a function I've added that gets the tile that is directly under the mouse that you're when you're hovering over a tile, and then it returns the location of this tile, whether or not you hit, and the index. This is then the grid index that you hit. So in this case, I could then get, let's see, the grid units map, and I could find on this grid index, and then I can print to the screen, let's see, whether or not there's a unit here. So I'm just gonna print this boolean to see that. So if we now go back to this map and hit play, and then I hover over this tile and press Z, it says false because there's no unit. When I hover over this, it says true. So that is a handy way to debug as you're adding new features or testing out anything. You can use this function and then get any of these grid maps that you want, and then figure out what is currently placed in these arrays on the grid. So let's talk about how these arrays are indexed. So the way you might think about this is, and I put up a small Excel sheet here, is, I mean, an Excel sheet is really a two-dimensional array. You have one dimension which goes for letters here, A to F, and another one which has numbers here. And in an Excel sheet like this, it's very easy to to pick a particular cell in this case, or which would be a tile in the grid manager, and say, so this cell is obviously C2 and this is A4 and so on. So it's very simple to access stuff here. Now the thing is, in Unreal Engine blueprints you don't really have two-dimensional arrays, you have one-dimensional arrays. Though there are many different ways in which you can cheat to create something that functions like a two-dimensional array, and that is kind of what I have done. So in early versions of the toolkit, the array that underlied this grid, it was as follows. So we started at index 0, and then 1, 2, 3, 4, 5, and then the next one here would be 6, and then 7, 8, 9. So you would see then so in this case, if you would want to access what would be at A2, you would have to access index 6, for instance, and B2 would be index 7. So at any time it goes to a new row, it then just keeps increasing by the width of the grid. So if you are at a particular tile and you wanted to access the tile that is directly south of it, then you would then add the X size then of the grid, which would be a size of 6, since these are 6 tiles or cells. So that would be 8 plus 6, or here it's like 2 plus 6 would be 8, and so on. So, and to access the one to the east, you would just add 1 or subtract 1. Now this can get a bit abstract, so what I think we'll do is to actually create a new grid manager, a very basic one, from scratch, so that these concepts become even clearer. So back in Unreal Engine, I'm going to go to Content and just make a new tutorial folder for us to use, and here let's make a new blueprint. Just an actor, we'll just make it from scratch, and I'll call it BP Grid Manager for tutorial, and let's open it up. So let's think about what we want to do here. So I want to do something in the construction script because I want the grid to be generated as I place the actor within the viewport. And then what I want to do is to create a number of tiles based on values that I define in the public variables, and then have that be displayed as a grid then of meshes. So let's start by adding a couple of variables. I'll just call it the same as I do in the grid manager. So grid size X, this should be an integer, and it should be instance editable. And then I'll duplicate this and make grid size Y. So now we have the grid size. And at the start of the construction script, I want to have a for loop to loop for the appropriate amount of iterations to create the grid. So how many loops do we need here? Well, let's see. Let's put some default values on this, by the way. So I'll default it to the same as the grid manager. So 3 by 3. So this will be 9 tiles, right? Since we will have 3 by 3. How are we going to get this from these variables? So it will be then this one times this one, right? That will be the number of tiles that we have. So we just multiply these values together, and there we are at the last index. But it starts at 0 and then ends at 9, so this is actually 10. So to get the appropriate number of tiles, we have to subtract then 1. And there we have 9 by 9 tiles. And in this for loop, I then want to spawn the static meshes of the tiles. Now we could just spawn regular static meshes, but it's more efficient to use instant static meshes, which are better if you want to display a lot of tiles or a lot of static meshes at the same time. So we're gonna add a component here, and oops, instant static mesh, or we can use hierarchical instead, which is what I'm using in the base grid manager. But yeah, let's just use this, and then I'll just call this tile ISM for instant static mesh. We will set the static mesh to tile there, SM tile square, and yeah, it's fine as it is. We can see if we want to manipulate it more later. So let's compile. And now in this loop we want to add instances of this tile. So I just drag it in and add instance. There we are. And to start, I'll just, yeah, for compiling it doesn't allow us for a transform, so I'm just going to split this and compile. And now let's see. If I place this in the level, we have now a single tile. Now this is really 9 tiles stacked on top of each other at the moment. I'll try to set this up so that we can let's see, view both at the same time like this, so then we can see what happens here as we keep changing this construction script. Let's just make this a bit smaller, and that looks great. So first let's try to set the X transform of this instance. So yeah, in this case I'm just gonna be a bit lazy, since I happen to know that this static mesh has a width of 200 Unreal units. I'm just going to hard code that into here. So I take this index and I multiply it by a float and put this as the X location. If I now compile, we can see that it then expands in this X direction. Now if we do the same thing in the Y axis, we can see that we now have something like this. Now this is obviously not what we want, so we have to adjust this somehow. So every time we go 3 tiles in one direction, we want to have to loop back and not just keep going. But we can do this quite easily. So really for the X direction here, if I just delete or just disconnect this, so we have this line that we had. So after we go to 3, we want to go back to the start again, and then 3 more, we want to go back to the start again. And this can be easily done with a modulus node. So for those who are not used to programming, modulus is super useful. And you can look into any programming tutorial on how that works. But it takes the index that goes into this node and checks it against the number that we have input here, which would really be grid size X. And then it's if it reaches the number that we have input here, then it sort of overflows and goes back to 0. So if we input 1, 2, or 0, 1, or 2 into here, and this is 3, then nothing will happen. It will return 1 or 2 or 0. If we input 3, it is the same, and it overflows and goes back to 0. So if we input 4, it goes to 1, because that is 1 more than this, and so on. So every time we increase this by 3, it will then, what is returned here will return back to 0. So if we look back at our Excel grid again, here with a grid size of 6 in both directions, so since we have the grid size X in this case would be 6, so up to this point of 5 we are still just returning 5. But the moment we go to 6, we go back to 0, which we can use then to return the X location back to the start again. So if we compile this, we should see it happen. Yeah, so then it goes back again. The moment it is at tile here number 4, which is index 3, then that is the same as 3 and it goes back to 0. So when we multiply this by 200, it goes back again. So here we have 9 tiles that are overlaying each other. Now we want to do something similar with the y-axis, because if we input this, we see that we're still going like 1 in the y-axis every time. But we can't just use the modulus here because it's a bit different. If we look back here, right, every time we go in this direction, we are actually increasing by the entire size of the grid, right, or 1 dimension of the grid. So it goes here up by 6 and then up by 12 and so on. So we want this to still be 0. That's no problem because it's 0. We want this index of 6 to be returned as 1. We want this index of 12 to be returned as 2 and so on, so that we can then multiply this by the size of the grid mesh and place it appropriately. So we can do this in a very similar way. Just instead of using modulus, we just divide. So if I now divide by the grid size instead and compile, we see that we have our 3x3 grid. Now this is how it used to work in earlier versions of the grid manager. It does not actually work like this anymore. So I'm gonna explain how it works now and why I changed it. Let's see. Let's put this back here. Okay. So yeah, in the older versions that's how it was. Now I'm using a different indexing system and I'm going to tell you how. Or first I'm going to show you how it looks. So if I select the regular grid manager here, there is a grid option you can select here, which is pre-generate gameplay grids. So this generates all the like edges and indexes and all of this stuff beforehand now in the construction script. If this is unchecked, this happens when you boot up the game itself. But checking this allows me then to select display tile indexes, which we can do here. And we can see when looking at these indexes, they are changing in a very different way. It starts at 0 again here. But instead of going up by 1 in this in the x direction, it's doing it in the y-axis, and when going in the x-axis, it's actually increasing by 1,000 instead. Now, why is this? So I can explain the problems by looking at this here now. So indexing like this, it's all well and good if you have a consistent grid that is sort of where everything is filled up, and you also don't want to add anything in later. Because the thing is, if you have a grid like this, but you actually just have a room here, and there's like a hallway here and another room here and so on. So you have only part of this is actually filled up with stuff you're using. Now, if you're making like a large dungeon system or something, this is something you might want to do, and then you suddenly have to fill up this array with a lot of like 0 filled values that are just taking up memory for no reason. And I mean, for most games that's fine, and I had it like that for a long while, but when I started adding multi-level grids, so we have several overlapping levels, and then some of those levels might just have a couple of towers that reach to that level, but I still had to then fill an entire new size of the grid with basically 0 values to get that working. So that was a waste of memory, which is one of the reasons I changed it. Another reason is that what if you now want to, during gameplay, add new tiles outside of this grid? What would their index be? If you want to add a tile that is here that can be reached from this one, it can't be 12 because 12 is over here. So it doesn't really have any proper index to add something during runtime. So because of this, I changed it in such a way that the grid manager assumes that your grid is 1,000 by 1,000 tiles at the start. And since I am not actually filling up any of these indexes, it doesn't take up any memory. and then you can freely add within those bounds of 1,000 by 1,000 tiles during gameplay. Now the limit is because of the size, the maximum size allowed for an integer. So if for some reason you want to have a map that is bigger than 1,000 tiles in one dimension, then come ask me in the discussion thread on the Unreal Engine forums and I'll help you out. But I think 1,000 tiles is more than enough for most people, so that's how it is by default. So if we change it in this way, then we can see that this would then go up by 1,000 and 2,000. Let's see if Excel can be helpful here. There we are. It would go then in this direction, and then in the other direction it would be increased then by 1, and yeah, like so. And this is the way the grid would continue to be filled. And though it might look a bit weird at first, it's more intuitive after you get used to it too, because if you look at any tile, then you can see, okay, this is 3 here, and before these 3 numbers, that means it's 3 in the x axis. If it's 0, that means it's 0 in the y axis, and here is 2 in the y axis, and so on. So you get this sort of coordinate system that you can easily understand. And that is also universal and will be the same no matter how much you resize the grid and no matter what project with this toolkit you are working on. So to give a very basic illustration of this, we can then manipulate this function here to, let's see, whenever we press this button, we want to get to find if there is a unit to the tile directly south of it. So since we know that when we go south we are increasing by 1, so then I can just index here +1, and if we play and press Z here, then it says true, and here is false, and this is also false because we're getting the tile beneath it. So that's it for tile indexing. Now in the next tutorial I will be talking more about how to get several indexes in surrounding somewhere, or like for using for visibility and stuff like that. So see you in the next video.